Hello, my name is Trupiano, and I'm going to be demonstrating the Return to Work Safety Suite for CSI4999 Senior Capstone project. Just to reiterate a couple of points, to start with our product goal, to develop a successful production of a multi-modular project to keep workers safe when a company goes back to the office. Module 1 is a web-based symptom reporting dashboard as well as an administrative team dashboard to monitor, report, and take appropriate action. Module 2 is on-site hardware with a distance tracking algorithm implemented from a third party for a use case. So we're going to show you Module 1 and some of Module 2, along with insight on our development process, Scrum methodology, technologies, and tools used, research, and testing to make the final product. Okay, so first we'll start with the landing page of our project. This shows, welcome to the RTW Safety Suite, with links to our project GitHub and our project demonstration video, which will be posted later. So there's two interfaces to our project for this module. This is module 1, to reiterate one more time. The admin interface, the employee interface, and for easy accessibility to our project, we've got credentials listed for both. So let's start with the admin interface. So I'm going to go to the admin interface and I'm going to enter this username and this password. Okay, so that link to the admin page, and then this redirects to our login page. So first, to log in as an administrator, we use the credentials that we have here. So I'll type Trupiano and then the password Oakland1 with a capital O. And then here we see our admin dashboard. Now we see that there's 0 results here because no one has submitted any symptom reports for today. And we're going to show you what an employee would do to submit that. So we have several feature lists up here. As you can see, we made sure to reprint the username for usability so the user knows that, yes, this is me, Sal Trupiano is logging in. We have employee status overview and company-wide statistics. This is a historical company-wide statistics. And then employee status overview shows the employee statuses just for today. So let's go to manage employees first. So you can see we've got a ton of employees already in here. These are artifacts from our usability testing, our UX testing, which we've talked about in our sprint presentations. So we've got several features here. So you can kind of see these buttons. The first button here is going to be add employee. So let's add an employee. Okay, so we're going to do first name. We'll say test. Last name is going to be user. Username is tuser. Department, we can select any department. Engineering is fine. And then the password. So we'll say, so the password, we have password validation employed in here. So if we just type Oakland and then we say it's a regular user, it's going to say it must match the requested format, right? So it needs to have at least one number, one uppercase, one lowercase, and this is all for security of our application, and this is to further illustrate that we understand user privacy and that this is a privacy-centered application. So we'll say Oakland123 is the password. And this is a regular user. We're going to say add. Success, new employee added, test user in department engineering. So let's go down and find our test user. Here we go. Now there's several actions we can do with the user once we actually add it. So the first thing we can do is reset the password. So if I log in and let's say I want to reset the password. So I'm going to say reset to OU 1 2 3 4 5 6 7. OU 1 2 3 4 5 6 7. Great. Reset password. Now that's not going to work because it also has to have a lowercase number. So we'll make the U lowercase. Reset password. There we go. And let's say the admin made a mistake or this guy got promoted to, I don't know. You wouldn't really get promoted to maintenance, but let's promote him to maintenance. Save. And there we go. His department is now maintenance. All right. And then finally, if we want to delete a user, if the user doesn't, belong in the company anymore, we can say delete. So let's delete Cameron Mountain. Yes, we want to delete. C Mountain has been deleted, right? And we can also add a department. So here are the departments. Let's say we have a new department. We want to say administration. All right, add. Administration has been added, and then you can select administration from the list, and we'll put Colton Simmons in administration. So basically just some basic employee management tools that you see in a lot of applications, but we felt this is important to be able to identify each employee easily. And so, yeah, that's pretty much it for this view. The next view is going to be employee submission history. So this has, this is basically to keep a historical record of each employee that has submitted a symptom form throughout all of time. So we made each column sortable. So really the only thing that people would really care about, I'd say, is COVID positive and COVID exposed, but you can also sort by any of the other symptoms if you want. So I'll sort by COVID positive, yes, right? And we see Colton Simmons is positive. So we would say, Colton Simmons is not allowed, or this is for a historical record in case, you have to report your cases to the health department or however that would work. So Colton Simmons is positive. So that's pretty much it for this page. Distance tracking is the next page. We have a Ubuntu desktop machine, and our Ubuntu desktop machine is actually right here. Okay, so here's our Ubuntu desktop machine. This machine is responsible for running our module 2, which is the on-site distance tracking. So what the machine does is, it basically we have a Python script that we made called RTW capture. And what this RTW capture script does is it uses VLC to get a stream capture from a webcam we have set up on the desktop. And then it captures that video in 1920 by 1080 with the proper MPEG encoding for 30 seconds. After it captures that, it will save it using Python threading and the OS command. And then it's going to convert the MP4 file, or it's going to convert the AVI file to MP4. Then it's going to send the MP4 file to our social distance detection algorithm. And this algorithm was sourced from a website called PyImageSearch, and we implemented it to fit our own use case. So what this basically does is, after it's done capturing the video, it's going to send that video to our algorithm. And then once the algorithm processes it, this is the algorithm, the detection command. Once the algorithm processes it, we are going to convert it to an MP4, because MP4 is readable on the web. So we have to convert it to MP4 before we can rsync it to our Google Cloud server. And then we use rsync, which is a popular Unix command to send files. We use rsync to send this file to a user share directory on our Google Cloud server. And then we have it sleep for rest for 25 seconds. So basically every 30 seconds, it is capturing a video from the webcam. It sends that MP4 to our algorithm. Our algorithm analyzes the video. And then once the algorithm is done analyzing the video, it converts it back to MP4 from AVI, because the algorithm outputs an AVI by default. And then it will rsync, which is sending the actual file to our server. So that's pretty much it for that. The PyImageSearch algorithm basically works with OpenCV and cuDNN. And basically what that does is it uses NumPy and SciPy, which are two popular machine learning libraries in Python, to get an input stream from the camera. It detects the objects using the YOLO object detection libraries. And then it calculates the centroid, which is the center of the object. And then it will calculate the distance in pixels between the two centroids of each object. And each person is encased in a box. And then if they get too close, those boxes will turn red, and it'll say there are 2 social distancing violations or more if it detects it. And if they are far enough apart where the algorithm determines this to be right, then they will turn green. We can actually show you a sample video from one of our test runs. So each sample video is showed on the distance tracking page. This is basically, we use an Apache virtual host and an Apache alias directory. So this is actually pulling from the user share file upload directory from our Google Cloud server, posting the directory on here, and then when you click on a link, it'll open in a new tab with the video. So here we are testing this out. The algorithm, we obviously are not 6 feet apart, so the centroids turn red, And now we are 6 feet apart, and I get out of the frame, and we're fine. And so obviously you could see when we were too close, it said this number of social distance violations is 2. And so basically this is meant to be used as kind of security footage. So every 30 seconds, you're going to be getting a new clip of, your departments, wherever you have this set up. And then it says, okay, these people are fine, they're fine. Or, you look and say, oh my gosh, everyone's way too close. We have to make sure we keep everybody safe by going down there and telling everyone to stay apart. And that's pretty much it for our admin dashboard. So when the admin's done, we've got a log out function, and that logs the admin out. It unsets the PHP session, and you're all set. Okay, so now we're going to demonstrate our employee interface. So you can use these credentials. However, we did create an account earlier called T-User, so I'm going to log in with that account. So let's go to employee interface. All right, let's log into T-User with the password of OU123456. Okay, so here we are greeted with our dashboard. So we see we have an employee health screening form for today. We also see we have our employee information. So we get the name, your employee ID, and your department. Employee status. So this is the important part, right? So when the employee signs in, this can either be preset by your department or by your administration, or it's left for you when you report. So let's say there's an outbreak in your department, right? Like you've got 3 people in maintenance that have COVID. If there's an outbreak, then this will show up as you should stay home because there's an outbreak. Or if there's no outbreak and there's no administrative action, then it will just say you do not have a form entry for today. And this resets every day at 11:59 p.m. So at 12 a.m., if you sign into this page and you already submitted, it's going to look like this. And then we have a certification of results as well. That's basically for to tell the user, you certify that your answers are accurate and truthful to the best of your abilities. Doing so ensures you and your fellow employees are kept safe. And then, any false statements will be reported and any disciplinary action will occur, because obviously this is very important to keeping everyone safe when returning to work. So here's our employee health screening form. We have all of the CDC mandated questions in here. And according to the CDC guidelines that we followed, if you answer yes to either fever, uncontrolled cough, or shortness of breath, then you should quarantine and stay home for the day. If you answered yes to 2 or more of any of these questions, then you also should stay home. But if you just say, yes, I have a sore throat and nothing else, it will still let you in. So let's demonstrate that right now. So let's say I have a fever, but I have no other problems. I'm gonna put me in here. We're going to submit. All right, and now it says I have to stay home because obviously I have a fever and I should need to stay home. Great. So that's pretty much it that's all the employer has to do. And then now I can log in as an administrator. So I'll log in as an administrator. And then I see that test user is no, and John Doe is okay. So now let's say me as the test user, and we also use cursive font to make sure the signature is a little bit easier to see. So let's say me as the test user, I entered in that wrong, right? Like I said, shoot, I meant to say no, but I pressed yes. It's fine because we actually have an override feature here. So I can just override as the admin, and then I am turned to yes. So you'll then on the employee page for T-User, now I'm clear. So it's just an easy way for the admin to override in case there's any problems. And then obviously all of this is reflected in the employee submission history page as well. So now he's okay. Let's move on to our server infrastructure. So here's our Google Cloud infrastructure. So this is basically the server that we use to do it all. So we've got a compute engine instance that we use. It's running Ubuntu 18.04. It acts as a web server for the module 1, and it also accepts files that are rsynced from module 2, which we just showed you back there. And finally, the last aspect we wanted to show you was a full run of our module 2. So let's go over to our module 2 machine. And this is, again, an Ubuntu machine running on a desktop that we're remoted into. So to start, we want to open the social distancing detector folder. So we're going to do that in a terminal. And in this thing, we've got our Python file, which is sourced from PyImageSearch, which is the algorithm that we implemented for our own use case. And then our script RTW capture, which I demonstrated earlier. So let's run RTW capture. Python 3 RTW capture. Let's enlarge this just a little bit. Okay, so what it's doing right now is it's getting a VLC stream of our webcam that we have installed. And if I stand right in front of it, it should actually see me. And you'll be able to see that it outlined me in a box. And then what it does is it records the stream from the webcam with VLC for 30 seconds. And so now that that's done, it's cooling down for another 5 seconds while that video is able to save and write to disk, because VLC takes a little while. And now you can see what it's doing is it sent the video file to our algorithm. And this algorithm is opening an OpenCV2 frame, and then it's going to basically show, what it captured. But you can see me coming out of my desk. I'm kind of bound by my headphone cable there. It can see me, and it's outlining me in green. And if there was someone else here that was way too close to me, then it would be red. And now you can see that it converted the AVI output from the algorithm to an MP4, and then it's now rsyncing that file to the server. Okay, and now we are at the Avid distance page, and you can see 425 right here. So let's take a look. You can see me, and here I am. And so that's kind of how it's going to work, right? It's going to act as security footage to monitor distancing with a slight delay. And as you can see, the algorithm just keeps looping and looping and looping infinitely until it's stopped or until the computer is restarted. That is all we have for today. Thank you very much for watching our project demonstration, and have a good day.